Hey everyone, and welcome! Today, we're going on a pretty amazing journey. We're going to take thousands of pages of dense historical text and transform them into a single, clear, visual argument. So let's dive right in. Okay, take a look at this. Right now, it probably just looks like a complicated web of dots and lines, right? But this is our destination. It's a map of ideas, a visual breakdown of competing historical narratives, all pulled from a massive archive. And trust me, by the end of this, you'll understand exactly how we got here.
So this is the big question, isn't it? It's the core challenge for anyone working in the digital humanities. You've got this enormous archive just full of rich, complex language. How in the world do you analyze it systematically? How do you zoom out from just one or two passages and see the entire intellectual landscape all at once? Well, that's exactly what we're going to answer today.
Here's our game plan. We'll break it down into 6 parts. We'll start with the challenge itself, then we'll walk through our 3-phase workflow, using AI to read and describe documents, then preparing that data, and finally turning it into a network visualization. After that, we'll learn how to actually read the thing, and we'll wrap up by talking about why this open source approach is such a game changer.
So here's the thing you have to remember. Historians work with more than just facts. They work with ideas, with arguments, with entire ideologies. But how do you actually track something as abstract as an ideology across hundreds of different sources? I mean, doing it by hand is a truly colossal task. But digitally? Well, that requires a really smart workflow to turn all that raw text into data we can actually work with.
To pull this off, we're going to follow our data on a journey. We'll start with just a folder of raw documents, and we'll guide them through what I like to call a digital workbench, a set of 4 incredible, free, open-source tools that all play together perfectly. You can really think of it as an assembly line for producing insight.
Okay, phase 1. Our journey starts with the first tool on our workbench, Vidia. This is the real heavy lifter of the group. Vidia is designed to automate what is easily the most time-consuming part of archival work: reading, describing, and cataloging documents, all with a little help from artificial intelligence.
Vidia's process is pretty straightforward, but it is incredibly powerful. First, it uses something called optical character recognition, or OCR, to basically pull the text out of scanned documents. Then, and this is where the magic happens, it sends that text to an AI to generate these rich, analytical descriptions. And finally, it automatically uploads the document and all that new data into a digital archive system called OmegaS.
Now, what's so cool about this is that we're not just letting the AI run wild. No way. We're guiding it with human expertise. This here is a little piece of the actual prompt we give the AI. We're telling it to act like a specialist and to use a conceptual dictionary that we created, basically a list of analytical tags to categorize the text. The AI isn't our replacement, it's our superpowered research assistant. And check this out. This slide shows you exactly what that looks like in practice. On the left, you've got a sentence from a classic Brazilian history textbook. On the right, you have the structured tags the AI generated based on our instructions. It sees the sentence is part of the Bandeirante epic, it tags the actor as a Bandeirante hero, and it identifies the event as immigration and colonization. Just like that, a subjective sentence becomes structured data that we can compare and analyze.
All right, so all our documents are now tagged and neatly organized in our digital archive. We're moving into phase 2, the not-so-glamorous but absolutely essential work in data preparation. This is where we get our hands dirty and get the data ready for the main event. For this part, we use 2 more tools. First, we use OmegaS's built-in bulk export function to just pull all our data into a single file. Then, we bring that file into a tool called OpenRefine. If Vidia was the research phase, then OpenRefine is the data's training montage. It's where we whip it into shape for the big finale. Now, when the data first comes out of OmegaS, it looks kind of like this. It's a mess. All the information we need is in there somewhere, but it's not in a format we can use for network analysis. The connections between authors and ideas are all buried in this jumble of text.
But then, after a little bit of work in OpenRefine, bam, you get this, a perfectly clean, perfectly structured table. We've used OpenRefine's tools to clean everything up and pivot the whole data set into just 3 simple columns: a source, which is the author, a target, which is a single theme, and the type of connection. This simple structure is the golden key that unlocks everything else.
And that brings us to the grand finale, phase 3, and the last tool on our workbench, network visualization. We take that clean 3-column table and we import it into a program called Gephi. It's a tool designed specifically to turn that kind of relational data into these beautiful, analytically rich network graphs.
So once we're inside Gephi, we can really start asking some deep questions of our data. See that statistics panel? With just a single click, we can run these complex algorithms that tell us how important each theme is, or which ideas tend to cluster together. All sorts of amazing things.
But what do these techie-sounding metrics actually mean for a historian? Let's translate. When we calculate something called degree, what we're really measuring is relevance. A theme with a high degree is super important in the overall conversation. And when we calculate modularity, we're basically detecting communities, groups of ideas that are so tightly connected, they form their own little intellectual neighborhood.
So by running those statistics and then applying them to our visual, using degree to control the size of the dots and modularity to control their color, our data's journey is finally complete. What started out as thousands of pages of raw text is now right here, in sharp focus, a network of meaning, a map of an entire intellectual world.
But hold on, because making the graph is really only half the battle. Now comes the most important part, the human part. We have to interpret what this visual argument is actually telling us. This isn't just a pretty picture, it's a whole new kind of historical document, and we need to learn how to read it.
And the great thing is, reading it is actually pretty intuitive. Remember our metrics? The size of each dot or node tells us its relevance. So the bigger the node, the more central that theme is to the whole discussion. And the color? That shows us the communities. So for example, all the green nodes represent a cluster of ideas that are always being discussed together, and they're distinct from the orange or blue clusters.
Okay, let's zoom out and look at the big picture for a second. We've just walked through a complete end-to-end workflow for turning text into a network. And what's truly revolutionary about this is that every single tool we used is free open-source software. This is our digital workbench. We had Vidya, which automated the reading with AI. We had Omena S to manage the archive. OpenRefine was our data cleaning powerhouse. And Gephi brought it all to life with visualization and analysis. The whole shebang, a professional-grade workflow, and it's accessible to absolutely anyone.
And that's the key takeaway here. This workflow doesn't replace the researcher, it empowers them. By automating all the heavy lifting of processing massive amounts of text, it frees up our most valuable resource, our time, for what we humans do best, asking tough questions, putting things in context, and building truly nuanced interpretations.
So we've shown you how to draw the map, we've given you the tools and the compass. The only question left is, when you apply this to your own archives, to your own research questions, what new worlds will you discover?